Okay, so we talked about the addition rule last time. So in the addition rule, we were looking at the word or. In this one, we're going to look more at the word and. So these are what we call independent and dependent events. So this is what, and then eventually it will lead to the multiplication rule. So we say two events are independent if the outcome of one does not affect the other. So if you think about one particular event not affecting the other, you can have like flipping a coin. So if you have a coin, you cannot get, if you get heads the first time, so heads first, that is not going to affect the outcome of the second toss. So even though I get heads first, that doesn't necessarily mean that tails is more likely or heads is more likely. So whether I get tails or heads, it will still not affect the fact that I got heads first. So the coin basically has no memory, so I can get the same thing, either tails or heads. So that's what an independent event is. Now, things that depend on one another or that are not independent is what we call dependent events. Okay, and the best way to really understand this is when we say keywords like replacement. So when we talk about replacement, we have to be very careful when we talk about these two different types of events, because what the replacement means is that if I am sampling, and I'm going to write it down, sampling with replacement, okay, that means that I am replacing whatever object I got. So this is, I literally, let me write it this way. Let me write, put it back. Put it back. Okay, so if I am getting a particular object and I am saying that I'm sampling with replacement, means that I literally just put it back. If I say that I'm sampling without replacement, so without replacement, then this is completely different. This just means that I'm not putting it back. So I take it away. So I take away. So I know it's a very simple, it's a very obvious, it's very obvious. Well, if I have with replacement, I'm going to put it back. If I don't have it with without replacement, I'm going to take it away. But it can be sometimes very confusing. So if you think about the two different types of events that we have here, we have independent events and we also have dependent events. So which one do you think would be with replacement and which one do you think would be without replacement? Well, if I know that I'm replacing it back, that means I really haven't changed anything. So if I had a bag and I had a whole bunch of different colored marbles in there, like let's say I had a couple green ones, I had a couple orange, yellow ones, and I had a couple red ones. Well, if I got a red one and I went ahead and put it back, well, it's just like as if I didn't really get the red one in the end. So sampling with replacement is actually independent. Okay, because the outcome of the first one is not going to affect the outcome of the second one because I didn't change the number of items in the bag. Okay, now, however, if I'm sampling without replacement, I'm taking it away. So now if I got this red marble and I got rid of it, now I have one less. So this sampling with replacement is a dependent event because it depends on the first draw. Okay, now usually there is a formula attached to thinking about dependent and independent events and replacement. And the formula is what we're going to call the multiplication rule. You don't need to memorize this formula and you don't need to use it. We will use it mainly when we talk about conditional probability. But basically what this is that if I want to figure out the probability of one object and a second object being chosen, this is going to be equal to the probability of A times the probability of B given that A has occurred. Now this part, this PB given A, the way that we say it is probability of B, that little line just means given A. It's what we call conditional probability. And we'll talk about that a little bit later on Monday or Tuesday, whichever class you're in. Now this just says that I take the probability of A occurring, so A occurred. Now, the probability of B given A, so A just represents, did I replace the marble or did I not replace it? So probability of B is going to be different depending if I replace whatever I got in A. Okay, so you don't need to use this formula. You can just use common sense. The only thing that I will say is that when you're doing the multiplication rule, here you're gonna have to have multiple trials. Okay, so you cannot do it in one trial because we know that for example, if we toss a coin, the probability of getting heads and tails is going to be 0 because those are disjoint events. So you have multiple trials. We don't have one trial. Okay, so let's go ahead and do an example of this. Okay, so let's go down here. Okay, so here is going to be my example. So I have a bag contains 3 red chips, 4 blue chips, and 5 black chips. 1 chip is drawn at a time. What is the probability of drawing a red chip? Okay, well, let's first think about how many total chips we have. This one doesn't necessarily deal with any multiplication rule. It just literally wants to know what is the probability of getting a red chip. So the probability of just getting a red chip, well, I know that there's 3 red chips out of the total number of chips that I have. This is just going to be 12. This is going to be 3 out of 12. You can reduce the fraction if you want, but that's not really necessary. Okay, what is the probability of drawing a green chip? Okay, well, I know that, well, notice that I only have red chips, blue chips, and black chips. There's no green chips, so the probability of getting a green chip is going to be 0 because I don't have any of that in this bag. Okay, so now suppose you drew a red chip first. Okay, if drawing with replacement, what is the probability you draw a second red chip? So one of the key words here is drawing with replacement. And what we're taking into account is what is the probability that the second is a red chip. Okay, so I don't really care about the first red chip being chosen. I know that I have the bag. Okay, here's my bag. I got a red one. Okay, but now if I'm drawing with replacement, that means I'm putting it back in there. So that means I haven't changed the number of chips that I have. So I still have 12. Now, what is the probability that you draw a red chip, second red chip? Well, I haven't changed the number of red chips that I've had, so this is still going to be 3. So it's still going to be 3 out of 12. Okay? Now, part D says, suppose you drew a red chip first. If drawing without replacement, what is the probability you draw a second red chip? So it's the same exact problem. The only thing now is that now I have this red chip that I just drew. Now I'm not putting it back in the bag. Okay, so now that's going to decrease the number of items that I have. So now I only have 11 items. Okay, now I no longer have 3 red chips since I got rid of one of them. So now I have 2 red chips left. So I have 2 out of 11. Okay. So what you got to do is really keep track of all of these keywords. Look at the keywords. Make sure that you're keeping track of all of these marbles or chips or whatever I gave you. All right, so what is the probability of drawing 2 blue chips in a row with replacement? Now, here the key word is in a row. So in a row means that I get the first one being blue and the second one being blue. Okay, that's what in a row means. So whenever you see the word in a row, that just means that I'm getting a blue chip and then I'm getting another blue chip. So that means the probability of getting the first one blue and the second one blue. Okay, well, the and just means multiplication. Okay, so drawing the first one blue. So I have 4 blue chips. So this is going to be 4 out of 12. Okay. And I'm going to multiply it by the probability of getting the second one being blue, given that the first one was blue. So if the first one was blue and I replaced it, that means that I didn't change the number of items that I had. So I still have 12. Did I change the number of blue? Nope, it's still going to be 4. Okay, so this is going to be 16 out of 144. Okay, that is going to be my answer. Okay. All right, so notice in this one, it was very different because we were taking into account both events. We were looking at the first one and the second one, whereas the other one, I was just interested in my second draw. Okay. Part F, what is the probability of drawing a red and then a black chip without replacement? So what I want is the probability of the first one being red and the second one being black, and I'm not replacing it. Well, the probability of getting the first one red, okay, we know that it's 3 out of 12. And the probability of the black chip, of the next one being black, is 5 out of 12. But notice that I'm doing without replacement, so I'm not replacing it. So that means I got rid of the red chip that I had. I got rid of it. So now I only have 11 left. And then how many black chips do I have? Well, I didn't change the outcome of black, so I'm just still going to be 5. Okay, so this is going to be 15 out of 132. Okay. All right, so we're almost done. And all we just need to do is these last two problems. What is the probability of drawing 2 red chips in one draw? Well, remember that and if we go back to the question, it says that 1 chip is drawn at a time. So is it possible for me to draw 2 red chips in one draw? Nope, not possible. So the probability of getting 2 red chips in one draw is going to be 0. Okay. Now here's the last one. The last one is, what is the probability of drawing a blue or a black chip? So the key word here is or. So remember that or doesn't deal with multiplication, it deals with addition. So here what we want to do is trying to find the probability of getting a blue chip or a black chip. Okay? And remember that all we got to do is just add these probabilities. It's not in 2 different trials, it's just in one trial, but I can either get a blue or I can either get a black. So I can get a blue 4 out of 12. Or I can get a black 5 out of 12. Okay. Now notice that I'm not going to subtract it by the probability of getting a blue and a black, because notice that I cannot get that. The probability of me getting a blue and a black at exactly the same time is going to be 0. Okay. So this is just going to give me 9 out of 12. Okay, notice that the math is very simple. The only thing that's a little bit difficult is trying to keep track of what exactly I'm replacing and what exactly I'm not replacing. Okay.